Hi, this is a video for 9.4, Modeling with Exponential Functions, out of your Jacaranda book. So this says the decay of a radioactive substance is modeled by, and they give you an equation, Q of T equals Q naught times 2.7 negative KT, where Q is the kilograms, is the amount of the substance present at T years. So Q is an amount in kilograms after T years. And it's the amount present. Okay, so if I'm looking for how much is decayed, this is not it. All right. Now it says Q naught and K are positive constants. Let's just talk about that for a second. I think we've done it already, but we'll do it again. This thing is the initial value.
Oh, hi.
Hang on one second, girls.
Just me.
All right, so we know that K naught, we call it K naught because that's a little zero there, is the initial value. So how much of the radioactive substance in this thing you're starting with? This K is called a constant of proportionality. And really, it's just what builds our exponential equation, and if it's negative there, then we know that the amount is decreasing. All right, so A says, show that Q naught represents the initial amount. So I'm just going to do that. I'm going to say, okay, Q of 0, because that's when time is 0. That's what initial means, right? Is Q naught times 2.7 to the 0, because T is 0, that whole thing is 0, and anything to the 0 is 1, so that's just Q naught. So when time is 0, I get that initial value. Okay, part B says, I don't know why I'm writing in red pen. Part B says, if the half-life of the radioactive substance is 100 years, that means in 100 years, I'm going to have half of what I started with. Then I want to calculate K to one significant figure. All right, so half-life. So in here, listen, I don't know how you want to think about this, but I like to do this. I think any amount I want. So I started with 100, what's this in? Kilograms. Okay? You can pick whatever amount you want. So I started with 100 kilograms, and I did 2.7 to the negative KT, and the amount remaining, half-life, is 50. Now, I know in this particular instance that the half-life substance is 100 years. So T is 100. So let's see what equation I have. I have 50 equals 100. Now, could you have picked, think 1,000 and put 500 here? Yeah, it doesn't matter. Okay, it doesn't matter which one you pick. Pick some value and then have it. Times 2.7 e to the k times 100. All right, so I'm first going to divide by 1,000. That's always the first step, and now you'll see something really good. There's always a half ends up here, because it's the half-life. I can see I'm going off the edge, negative 100k. I'm trying to solve for k, and I'm in it's in the exponent, so I'm going to use my rewriting tool, and I'm going to go log base 2.7 of a half equals negative 100k. Well, I definitely need a calculator now, so I'm going to get that out. Sorry. And here I am on my calc, and I go to math, and I go all the way down to below here where I get log base, and I hit that, and I go log base 2.7 of a half. I'm just going to put 0.5 for the sake of it, and I get a value. So I get negative 0.6978, and I'm going to put dot, 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 and that shows the person marking this that I am using my calculator value. Negative 100k, and so k equals that divided by 100. I get negative 0.00, and I think it said here to one significant figure, so 7. If I'm rounding to one significant figure, it's 0.007. All right, great. And then part C says, I'm going to do it right here. If initially T equals 0, there was 25 kilograms of the radioactive substance, how many kilograms would decay in 10 years? All right, so I want to know, after 10 years, I started with 25, and I know what K is. It's negative 0.007 T. How many kilograms would we decay in 10 years? And they say use the thing from part C, so I'm going to do that. All right. Oh, this is a 10. All right, so I just typed this in. 25 times 2.7 to the negative 0.007 times 10. And I get Q sub 10 equals 23.32. All right, now, that's how much remains. And they're asking me how many kilograms would decay. So I need to do the initial minus how much is remaining to figure out how much has decayed. So I go 25 minus that answer I got. I get 1.7, we'll just say. Therefore, 1.7 kilograms has decayed. That's it.